Fair enough. So, welcome everybody to the This Week in Machine Learning Fast.ai TL study group. As has been announced, we are restarting the lessons for the version 3 or the 2019 course, I must say, for the Fast.ai DL. And we will do the lessons one by one starting this week. And this will be the first of that session starting today. So let me share the agenda for the day. So it's basically an intro of what the study group is all about. And then we have a couple of presentations. One is a presentation on the image augmentations that is used in Fast.ai. And you would kind of see that even in lesson 1 for people who are joining in new. And for people who have done this course as a part of the Fast.ai.live, they would be anyway be aware of this. But Sanyam would kind of take that in a little bit more detail and explain. Kindly consented to start lesson 1 review, and therefore we go on with the forthcoming lessons the coming week. And for that, we have discussions, and then we request for people to share their views, anything they want to kind of bounce things about, and then discuss on who would like to present for the next week study group and so forth. Okay, so these are your study group hosts starting from now. So these are the people who would go through the complete 7 weeks. As we know, these lessons take, and I think we should be right in time to be able to conclude and start the version 2 of the course when it starts, I believe, in mid-March or the 3rd week of March. What is the study group all about? The study group is all about is to get people together and make sure that our combined learning enforces what we go through in the MOOC. So of course, one is the Fast.ai channel that you have on the Slack, if you are a part of that. And there are a couple of channels that I believe. One is the DI tag channel, and the other is the ML tag channel. Any questions on the DL, we request you to put on the DL, tag for us to start about. And then as is the norm, we start with weekly sessions and hope to complete the lessons as we go along. Okay, so the format of this is going to be as explained. We will have hosts who will take up and we'll keep rotating. We will have participant present, even though we have given a time limit of 5, it is not absolute in any measure. Depending on the interest and the number of participants we have in a session, this is very much flexible and variable. The initial part of it was to keep pace with Fast.ai Live, but of course now is to keep pace with the MOOC, so as to say, and be in time for possibly the next version of the course starting mid-March. So that's the whole thing. And one of the things, as you would see when you see the kind of lessons from the MOOC, is the fact that it's very important to get into the habit of doing first, rather than get into the habit of looking at the lectures and starting to get too much into the concepts and definitions and getting stuck at that particular juncture. It's very important to do it, get your hands dirty, understand what's going behind it, so as to get a much firmer grip on this particular course, so as to say, and that should be the norm for any other course as well. Personally, I've been a recipient of being a participant in this particular study group, have had the courage to present a couple of times as well, and been a great learning experience, and it's always, I think, the experience of vast majority of others who are part of this particular study group and keeping pace with it. So that's more or less what I wanted to kind of talk about in the intro. Having said that, I would like to welcome all the first-time participants, so as to speak, who have joined us after the version 3 of this course, or the 2019 version of this course has gone live. We welcome you to this particular study group. Hope you have a great time learning along with us, and we look forward to contributing as well in form of presentations and discussions as we go along. So that's what I wanted to kind of complete. I think the next part is, I think, Sanyam, for you to take up and start the image augmentation session. So if you can take over, that'll be great.
Sure. Let me just share the links that I'll be quickly going through.
Sure.
Yeah, so I've shared the links in the Slack and the chat as well.
Okay, great. So I've stopped sharing. You can take up now.
So a quick answer. I've received a bunch of questions over my last presentation about these benchmarks that I had done. So all of these were in mixed precision. It's not FP16. Fast.ai by default goes to mixed precision. And the details are in the link. I talked about this in the last meetup. Also, this was the largest speed up that was noticed. And to the people that are asking that 1080 Ti doesn't support FP16, apparently it does. And from what I was able to learn, it's not best optimized. So if you're on a 1080 Ti, or if you're using a cloud instance, or if you're on the RTX cards, be sure to check out mixed precision so that you could sort of benefit from that. And one more notification, the Kaggle kernels are now, the Fast.ai lessons are now available as Kaggle kernels as well. And they do not take a lot of time to run in case you're wondering. So that might also be something you want to check out. All of the links are there in the chat. So initially, I wanted to do a experiment sort of walkthrough about the transforms, that what work and what doesn't work in what scenarios. But I did not reach any concrete conclusion, so to speak, because I'm sort of still experimenting, and I'm still not sure what works best in what case. So instead, I'll just do a quick highlight of all of the transforms that are there in Fast.ai, and also point you to the source code. I've sort of gone through the source code as well to check out how it's going on behind the scenes. And there's one more library that is just focused on image augmentation that I'll also highlight. So the number of transforms that Fast.ai supports are about 24. And one of the ways, like if you do not want to tune everything, you could just go get transforms. And this enables by default a bunch of transforms which are as follows. So what it does is do flip. This is like horizontal flipping. So your image, for example, will be flipped horizontally. And if you enable vertical to true, which by default is false, because in general, if you're just classifying regular images as in MNIST or dogs or cats, you wouldn't want them to be inverted, because probably no one would be clicking inverted images. So that's, I suppose, because of that reason, false. And then these are the other augmentations that are supported by Fast.ai. I'll just walk through them. So depending on your use case, you might want to check out all of the transforms that are there and toggle them on or off, or see how tweaking the value works. So the first one is, I believe, I think I lost track. Yeah, so the first one by default is the size, resizing the image, because if your data set has variable sized images, you might want to resize them to a uniform size. So whatever size you pass on to the transform function, it will be resized to that. And there are another couple of things that you could do with it. You could maintain the aspect ratio. You could squish the image just to make it that size, or you could crop into the image if it's a bigger image. So those are the few things you could toggle on and off. Then there's something called padding when you're resizing. So if you pad by 0, what happens is, as you can see in these examples, so to speak, 0 would just pad with, or put a border around with black pixels, as in 0 numbered pixels. If you have a border, it'll be like this, as shown in the few examples. And squish, like I said, would just squish the image to that size without caring about the aspect ratio. Then these are sort of the by default basics that are enabled. Affine transform and lightning transform. So what affine transforms are, sort of, I think you can call them geometric transforms. Just look at these images, you sort of get an understanding. I'm not sure if this is the perfect example for that. And the second one is warping. So this is sort of what warping an image does. So another thing is you can zoom and crop. So depending on what you set your scale and values to, it will zoom and crop the images accordingly. And then there is random resizing and cropping. So it randomly resizes and crops in and out or around the image randomly. There's some randomness to it. And all of these things sort of help to avoid overfitting in all of these cases. So if you're sort of just resizing with just one particular thing in mind, you might again overfit to those resized or those cropped images. And in essence, all of these steps are just to avoid overfitting and sort of generate more synthetic data, because like sort of transformed images would just be new images to the CNNs. Then there are randomness. So it's again some sort of randomness that's added to the transforms while resizing them. So the degree of rotation, so to speak, and all of the things combined would be randomly toggled on and off. Another thing is brightness. You can adjust the brightness. Then there is contrast. So ranging from a scale of, I think, 0 to 2, you can adjust the contrast. There's cropping in and out of the images, and also where you want to put the focus of the crop, if you want to crop into the center or towards the edges. So that can also be passed as hyperparameters. Then you have crop plus pad. So when you crop, do you want to pad the image or do you want to resize the image to whatever size you want? Then you have dihedral transforms, which is basically similar to a dihedron in the sense that your images will get rotated in those 8 possible angles that a dihedron represents. And you have dihedron plus affine transformation as well. And you have flip horizontally and flip vertically. For the vertical case, you might want to toggle that for satellite images or so on and so forth. In the cases where vertically flipping the image won't make you lose the context of the data in that sense. Then jitter, I think it just adds noise to your image. I'm not sure in what use cases this might be useful, but I'm still sort of experimenting with this. And then you have your perspective of, which is basically if you have your phone and how it would look when you move it around in a 2D image. So say your perspective is getting changed and that being moved to a 2D image.
Hey Sanyam, I have a question.
Sure.
So basically all these transformation, at what stage we are applying them? Are these a pre-process before we run the model, or are they part of when you're building a model and you pass the parameters, and these transformations are happening when we are running the epochs? At what stage we apply this?
From what I was able to understand, it is done during the pre-processing, when you're pre-processing your data set. So that's when you'll add more synthetic images to it by sort of these transforms.
So in a sense, if we have one image and we pass through number of transformation as you showed, so it will like replicate it, we create more and more images like
Yes.
for those transformation, and then it goes to the model as a whole.
Yes.
Okay, thanks.
Yeah. And then there are the standard transforms that are supported sort of by other libraries as well. These were sort of very specific to Fast.ai, in the sense that I personally haven't seen them with any other framework. You have your rotation, which is by how many degrees do you want to rotate your image. Then you have skew, so by in what direction and how much magnitude do you want to skew your image. And then you have the squish resizing, which is when you resize, you just squish your image. And you have your symmetric warp. Again, in this also you could toggle pad on and off, and you could have mirror padding or just zero padding. I would trust the defaults in these cases really well if you're not sure that what values you want to put, because Jeremy did mention that they had put a lot of experimentation behind those defaults.
And
Sandeep, if I remember correctly, these are, I mean, this is a lot more robust than even what was available in V2 Fast.ai. Have you explored applying these different transformations kind of in bulk to any of the problems, and what kind of results did you see in terms of either accuracy, performance, or generalizability?
I was trying them with CIFA 100. So I actually plan to demo that this week, but again, I did not reach any proper conclusion that what was very helpful or what wasn't.
Okay.
But if like by default, what would make sense is generally helping. So just horizontal flipping or some random cropping and rotation is generally helping me reach better accuracies.
Yeah. Okay. And is the default now those kind of basic transformers, or are they including some of the more, I guess, exotic ones in the default?
I think when you call this function called get transforms, it just enables those few, like not the very nice ones, I think.
Okay.
These are the ones that get called by default.
Okay.
When I was using this, I was kind of like, when I only wanted to use the, I wanted only to change the size of the image, and also use get transforms for that, I think. And then if you don't want to use any other transformation, then you have to switch them off one by one. Yeah. So I don't know whether they've changed it. Ideally, I would like to, for example, only change the size and don't do anything else with the images. I was looking for that a while ago. I don't know whether this is still the same or whether they have changed it.
For those cases, you'll have to toggle all of these values to 0 if you're just calling this get transform function.
Yeah, I think so. Yeah, that's right.
Or you could just pass on the specific transform that you're looking into.
Thank you.
And about the source code where this is implemented, it's inside of Vision class, Vision for a module, and it's just this transform.py. So these are sort of all of the transforms that are there, and you have these different sort of padding modes, which is reflection, zeros, and border. And like as far as I could understand, the implementation is based on the scientific formulae that are behind it. For example, rotation, this is just 11th grade math, like 11th grade math from my country. So all of the implementations are based on those functions that are there. And these get returned in as something called TFM which is again defined in image, which is getting imported up in the top. And these get handled again by the image module. And one more library that I want to highlight that is very specific to this. It's been developed by some grandmasters from ODS.ai community, Augmentations, and I think I'm not sure if Fast.ai supports transforms related to segmentation, but that is something nice that this library supports. And apart from that, these are a few more functions that it supports: RGB shift, hue saturation adjustment. You can shuffle the channels in the sense that RGB get interchanged.
Why would you use those? I would be thinking that you don't want to change the color of the parrot, or I guess there is a reason to do that, but I'm just not quite sure why that would be.
Like the use case I can think of, if you have many red cars in your data set and you're training on cars to be detected, so in that case maybe.
Oh yeah, makes sense. Yeah, that's right.
But again, you have to be careful when you're working with microscopic data set that you do not want to enable this option. Then contrast and brightness are supported by Fast.ai as well, and some blurring functions are there. A few distortions, and specifically, I did not dive much deeper into this library, but they do support some transforms around segmentation also.
So this library is also PyTorch?
It can be integrated with PyTorch.
Okay, okay.
And in the, I think it's the salt identification competition, so they've shown a few demos around that. So you have your regular padding transform, and these are specific to segmentation, right? I'm not sure if Fast.ai supports these many exotic segmentation transforms. So you have your flips, you have your horizontal and vertical flips, rotations. And the challenge here is, working with the mask values, so to speak, that are there with the segmentation file. So you need to ensure that those are transformed in the correct manner as well. So transpose is basically flipping across the diagonal. And you have your elastic transform. So sort of the shape of the image is changing. And grid transform, again, these are like mathematical functions. I happen to know them because I am a CS undergrad. So that's where these names come from. If you look them up, you'll be able to find the proper definition answer. Then optical distortion and random size props. I think these are all of the transforms that I wanted to highlight.
Thanks a lot, Sanyam, for this. So, for many of the people who have tuned in and, taking this course for the first time, this might be a slightly more advanced topic for you guys. But wanted to say that this is pretty important topic also to get started with, because image augmentation is an important technique that needs to be there. And Fast.ai provides it in a much more depth and detail, as Sanim explained it, compared to the other platforms that are available. Having said that, I will also kind of publish a link here on a YouTube video that you guys can go and watch, where one of the students who took the Fast.ai version 3 of the course via fellowships had done a much deeper review of the code for image augmentations. I think it's a person by the name of Akash, who is a part of Data Science India's course. I have published that link for all of you to kind of go and see and understand in detail if you so wish to do. By the way, thanks a lot, Sanyam. And as Jeremy mentions, much of this, what is available in default without you doing anything is covered in Fast.ai. But of course, as the data set and as the problem that we tackle varies, you might want to tweak it and take all of these other things that Sunny might mention into consideration as well, and make it relevant for the challenge or the problem that you're facing and you want to solve. Right. So the next one is the lesson 1 review. John, if you're there, you can pick up and share your screens.
Okay, just give me a second. Let me just grab my... Okay, let me know when you can see my screen.
I can see it.
Okay, excellent. So I thought there was quite an interesting discussion going on in the chat about, which is a good tool to use to access the Fast.ai. The reason being, obviously you could use AWS and so on, you've got to pay for it. And then more recently, the Google Collab came out, and then I think just a little bit earlier was the Kaggle kernel. So yeah, so if you want a free means of accessing the content from Fast.ai, then Kaggle kernels and Google Colab are two options that you have. If you want documentation on Google Colab, that's actually available on the Fast.ai site. And if you are looking for, and then obviously just go to Kaggle and you'll be able to find the Fast.ai kernels there. Remember, you're looking for version 3 because there's been a version 1 and a version 2, of course. Just to give you a big picture view of what we're trying to do in lesson 1, what I've done is I just made a couple of notes from lesson 1. So if this is not helpful, that's absolutely fine. But basically what you're trying to do here is just get used to the Fast.ai API. So things like, how do you create a data bunch? How do you ensure that you are able to label your data in a way that makes sense? Because sometimes your data might be stored in several folders, as has been common over the last couple of years with image data, but alternatively, it could be stored as the actual name of the file, as in the example that Jeremy gave, or it could be, it could be stored elsewhere, or it could be in a CSV document, for example, and you've got to try and figure out how to label. So those are some of the things that you need to think about, and those are and these are the sort of things that are covered when we look at the data bunch and so on. But just trying to get a high-level view of what we're trying to achieve. So in this first lesson, basically what Jeremy is doing is he's and my apologies, I don't I don't want anyone who's done the deep learning stuff before to think that they have to suck eggs. But I'll try and give a very quick summary. I mean, what you're trying to do really is to take a deep learning model that has been used in the past and that we know has been really successful with images. And we just try and reuse it for our data set. So in the
John, I think there is a request for you to, if you can make it bigger, people are not able to.
Oh, yeah, sure, sorry.
Bottom right corner, yeah.
Okay, so the big picture is that we're trying to use a model that has been trained on another data set, and we know that it's done a really good job on that. And then we try and then we take advantage of the fact that it's probably taken someone a while on a couple of GPUs, probably several hours to train that model, and we're then going to be able to do what's called transfer learning, where you have your problem set, and by transfer learning you're able to basically keep the same model that has been used, that this other person has created, right? And all you're doing is you're just going to knock off the head of that model and put what's relevant to your data set. So just to give you an example of that. So there are a couple of really well-known architectures. So there's things like VGG, AlexNet, GoogleNet, and so on. And all of these models have been really good and have won these ImageNet competitions, which is where basically these models had to classify 1,000 different classes of information based on thousands and thousands of images. And it's a good chance that if something has been trained on that it's going to do a reasonable job if you have an image problem, right? And so you don't have to have all of the pain of training a GPU, of training your model from scratch, because you can actually get the weights and the model that has won these competitions. And this is why, this is one of the really great benefits of deep learning. And so that's basically what we're doing. And in terms of what we're trying to achieve in terms of the Fast.ai part of this thing is to understand how we can actually load the different parts of the data. So just to give you actually let me stop there. Does anyone have any questions around what we're trying to do as a general exercise? Okay, so moving on to what exactly we're trying to do then. So clearly one of the things we have to do is to load the data. Now you can do that So again, it depends on how your data is stored, right? So if your data is stored as several subfolders, where typically each folder would contain the same object type. So let's say you were trying to distinguish between five different, or like in the pet example, I can't remember how many different pets there were, but let's say there were 100. Then each folder would have identical, or would have that same pet. So if you're talking about a German Shepherd, or if you're talking a certain breed of cat and so on, they would all have exactly the same they would have exactly the same species within a folder. That's one of the ways that you can actually access the data. That's one of the ways the data is represented. Those images are stored within folders, and that's the typical. That's sort of the historical way that data has been stored in ImageNet type problems in the past. But clearly there are going to be other ways, right? So for example, there's going to be, some of your data is going to be in a CSV document where you've got a mapping between the actual image names and labels for those data. And so what's really nice about the Fast.ai APIs is it gives you tools to be able to do that. So Jeremy's example was, for example, where you can actually get the labels from the file names, okay, using regular expressions. And so this is the one where, by using this regular expression, you could determine, or you could create the labels for your data set in this example. He also provided another example with the MNIST data set where, again, that was, I think, by folder names, but you can again do it by function names where, if you know that all of the numbers are stored in a certain folder, then you can label those and map those. And that's really important, because what you want to do is what you're doing is you've got the original model that you've gone and got from, that you're going to reuse by using transfer learning. And then I said that we actually knock off the head, because in the original models, right, what they were trying to do is this ImageNet problem or competition where they actually had to map it out to 1,000 classes. Now, in your case, you might not have, you probably won't have 1,000 classes. And in the example that Jeremy gave with the pets, I think it was around 100, I can't remember. But you obviously don't want the output to be 100. And so that's why you knock off the head. And then you've got to add your own head, which creates those number of classes, so 100 or 50 or whatever, depending on how you've divided up your data. And so that's what we're doing. So after we've loaded the data, we figured out how we actually want to separate out the different parts or the images that we're going to be doing. We want to distinguish, right? We then go into what's known as the data bunch object, right? And so another thing that you might have been interested in is, what are we doing by this normalization? Because when you do any, as part of getting the weights and that model, when you reuse that model, one of the things you'll also need to do is to get some normalization figures which are available when those models are released. And that ensures that there won't be any problems when you actually reuse that data. So you can do things like, you specify where the path to your images. You specify things like, in this instance that Jeremy gave was, with regular expressions and so on. But so Jeremy's example was from name and then using RE, which is the regular expression. But one of the things that would be really good is if you can try, for example, from name, and then there's like, for example, from name folder or from name function and so on. And depending on your data set, you'll be able to, depending on how different it is, you can use these different functions so that if you end up in a situation where you've got this different data set, it's not in different folders, you can actually, very quickly be able to create these labels so that you can load it into these data bunches. 2 to 4 is really common because that tends to be a typical size that you'll find for most models. Then the next thing you probably want to do is to display the batches, just to make sure that what you're expecting to see in terms of the labels are what you do see. And so that allows you to have a quick look at some of your data and make sure that that's correct. Clearly, if there's a problem there, you'll need to want to go back to your data bunch and try and figure out where you've perhaps where things are going wrong.
John, just a quick question.
Yes.
Could you normalize? Could you go over the normalize function again? So we are passing the images, And are we saying normalize the past images to image data bunch? Could you go?
No, yeah, sure. So what we're doing when we're doing, so as part of the original training of the data with the ImageNet data sets, in order for you to reuse some of that data, you need to normalize that. And so it allows you to make sure that when you use that data, you are making those same changes to the data. So that's a change to every image so that you can reuse that. So that when you are using the model that has been shared with its weights, you can use that as part of your transfer then.
Okay, all right.
Okay, so
I request participants who are not
Sure.
speaking to mute themselves, please.
Okay, I had a question. So
yes.
can we use other file formats as well, or is it only JPEG? It can understand only JPEG.
No, you'll be fine with PNG and other image formats. In fact, you can probably look at you can look within the, and this is where it's really, this is why Fast.ai is quite helpful. You can what you might want to try is go to go into, for example, if I can find it. I'm sorry, I don't have a notebook that I can just whip up very quickly. But what you can do is, what I'd suggest is go into one of these files and do all you need to do to get a little bit more information about a function. Jeremy showed you the doc and so on. You can also just provide the name of that function and then 2 question marks, and then gives you the source code. You can find there that for image files, it defines what an image file is, and it gives you that it has extensions JPEG, PNG, and so on. So that's your best bet to find out.
Thank you.
Anyone else have any input on that point?
Yeah, this is Marcello speaking. I have a question as well. I've tried out the image data bunch from a DataFrame, which I found very useful because I can just associate file names and path name to the classification, to the class. But what is confusing me is that I have to put the path sort of 2 times, because there is the path argument in the function, which appears to be mandatory, and the file names in the data frame. So can you elaborate or explain a little bit what is the reason of having the path 2 times?
So I haven't tried the data frame. So I haven't tried from name data frame. Does anyone else who's tried the data frame function who's had some success with that, want to chip in?
It's Charles here. I tried it with the CSV, and it was, I took most of the parameters out, and it seemed to work quite well. I know what you're talking about. The first 2 parameters of the function seem to repeat themselves. I've got it somewhere, but I've forgotten how to do it. Bear with me a sec.
Just one question for you, Marcello. By any chance, are you actually specifying the labels as one of those parameters? Because you do need to specify what labels are. Is that, or are you actually specifying a column as a label distinctively?
Yeah, actually I have 2 columns, but honestly, at the end, actually, I was able to work with it. I mean, it's I just had to put the path as a sort of the root of the root directory of the images. And then I managed to put the file names relative to that root path into the data frame in 1 column. And in the second column, I had the labels. And that was working. But it was a sort of, I'm not sure if it is the right way of using it. Maybe it's the same thing as a CSV, I presume.
Yeah, with the CSV file, I played around with it for a long time, and then it worked with the path as you've just described, and then just the name of the training data, the folder holding all the training data. And then the labels is, you don't even have to put it. Takes that as a default item. And then you enter the transforms and size and normalize, etc.
Okay.
Does anyone else who tried the from name with data frames have any comments? Okay, I'll give it a try to Marcello. What's your handle on the Fast.ai channel? Is it Marcello?
Yes, it's Marcello.
Okay, fine. Okay.
So the question about this data frame, is it, are we saying like instead of individual path underscore image and a f name and a pattern, instead of that we store that into a data frame and pass that in this image data bench? Is
no,
that
what we're saying is you can use from name and folder as you know how you're actually going to populate your how you're going to create this image data bunch. You can use regular expressions, you can use folders. Alternatively, you can also just use a data frame. And so I think there's an option from name or with CSV, which allows you to do that. So it's where your labels are stored, basically.
Okay, thanks.
Okay, great. So this is where, so interestingly enough, well, actually, let me just pause there. Any questions from anyone at this point?
I've got one about the get transforms. That's just listing the transforms you're going to apply. Nothing's being actually transformed in that function, is it?
Well, actually, if you look at the get transforms, there's a whole load of default ones, you know, so flip and so on. When Init 27 went through the different augmentations, there's a whole load that are specified there by default. So yes, you get those ones. But if you want to...
The question is when does the transform happen? I think another person asked this question. It's not there. It's when we're doing the fitting, isn't it?
Yes, that's part of the learning, yes. Yeah.
It stays in your memory. It doesn't get outputted, but it's done while you're training your network. And then there's something called TTA, test time augmentation. That's invoked when you want to test it. So that also helps boost your accuracy sometimes.
So just to recap, if you're doing a batch of 64,
right,
and you take one image and then you transform it as many times. So let's say we transform it 20 different ways.
Mm-hmm.
So we're then taking 21 images and as the first image of that batch. So we're doing 64 times 21 images to train on in that first batch. You understand?
I suppose, yes, but I'm not sure how it gels with the batching. But it's done when feeding in your batches.
Yeah, I thought it's like you get just, you know, every time you get a batch of 64, so you have a new batch of 64, right? So you apply, so basically in a way you do 100 epochs, and every batch has a new set of images because you have some transforms applied randomly to them.
Ah, got it. Great.
Yep.
Right.
Okay, great. So we come to then the list classes.
John, I think there is one more question on the
yeah,
chat.
sure. Sorry. Yeah, go for it. Can someone read it out? I don't have the chat open. Sorry.
Sure. So it says that it's from Damu. It says, what happens if we compile the regex pattern before passing it to from underscore name underscore re? Will it recompile or skip?
Okay, let me take a look at the questions. I didn't understand that. Sorry, can you read that out again?
Yeah, the question is, what happens if we compile the regex pattern before passing it to from underscore name underscore re? Will it recompile or skip?
I'm sorry, I don't understand what the question is.
So I don't know, but I can only tell you that in the current notebooks by Jeremy, it's exactly done that you do compile before passing it. So I don't think he'll additionally recompile again.
So I think that should answer the question. It doesn't recompile, right? Okay, go ahead.
Okay, I hope that's helpful.
No, the person has answered saying yes, thanks. Yeah, go ahead.
Okay, excellent. So one of the things that Jeremy showed us then was the data.classes and the length of that. And that's really helpful because that will tell you how many classes you actually have. Now, you might wonder, why do I actually care about how many classes I have? But remember, because we're reusing a model, right? We chop the head off and then we want to add our own head. As part of that process of adding our own head, we need to specify how many classes we have. And that's exactly where that data.c or the length that provides us that number of classes. So do you remember earlier when I was talking about how you take this really well-known model with its weights and then you add your own, so you knock off the head and you add your own head. That bit is actually done by this create CNN. Okay, so you specify the models and so on and the error rate, and then if you look at the code, as part of what you're doing is you then you create this new head with the number of classes as being data.c, and that's how it knows how many classes it should have as part of this new model. And then one of the things you'll have to do is you'll need to train this new head that you've added, right? Because it's going to have these random weights originally. So you want to keep your original well-known trained model. You want to train that new head, and that's what you do as part of this fit one cycle. Okay.
One quick question, John. So basically, we said that print data.classes will give us the number of classes in our images, our data set.
Sorry, can you start from the top again?
Okay, so we are saying, the print statement we have for data.classes. So you're saying this will give us our classes, whatever we are trying to predict. 2 classes, let's say we have 2 classes of image. So my question is, what function is determining the classes in our data? Because it looks to me we haven't trained our images as of this statement at this stage.
Right. So because as part of your pre-processing, right, when you create this data bunch, this is how you've actually determined what your classes are, because you've told your model that by separating out all of my images which are of one type into these different folders, this will determine, or this is one class and this is another class and so on, or by regular expressions or by function names and so on. That's how you've told your model that this is your means of separating or classifying or separating out these different classes, if that makes any sense. And that is how, that is how you've been, and that's the information that you've given your model with regards to, so the labels that your model needs and the data that your model needs. So you've given it the labels and the models, and that's how your model is then able to start this training element for your unique data set.
Okay, so in a sense, if I get it, that the image data bunch is going to pick up classes from a different folders, and that's where it's predicting that if we have a 7 folders, so it will say, okay, you have you're trying from 7 different folders, 7 classes. Okay.
Yeah, but that's the thing also, right? That's what's so nice about this thing, because it could be in folders, but it could also just be, your labels might not be in folders and it might not be in subfolders. It could actually be regular expressions, or it could be a whole lot of other things. Okay, so let's crack on then.
There is one more question saying that what is meant by head?
Head? Okay, sure. Okay, so apologies, I should have been a little bit more specific about that. Okay, so your model, if you can imagine your model having multiple, so these well-known models have multiple layers, right? So for example, if you say ResNet 18 or ResNet 32, 18 means it's got 18 layers, ResNet 50 means it's got 50 layers. When we talk about the head, what we're talking about is that final layer or couple of layers of the model, which you want to remove, because in the original model, the output was to be 1,000 different classes. So you remove that portion, right, which would include things like a softmax function right at the end. It would include things like a dense layer. So softmax function as in, so there's, you've got one layer doing that, you've got one layer which is a dense layer and so on. So you're removing, so that component, that final bit, which is what was used by the original model, is what we call the head, and that's what is being removed, and you are creating this new head as part of this create CNN function. Does that answer your question?
Yeah, so Jess is asking, is head is equal to output layer? Basically, head is the number of classes, Jess, that this new data set has, which needs to be predicted. All we are doing is trying to adapt the pre-trained model on the ImageNet, which predicts 1,000 classes, to be able to fit the number of classes which is there in the current data set. So yeah, in a way, you're trying to match the number of outputs you need to predict. Okay.
So I'm conscious of time, that we have only 6 minutes left, so, and frankly, that's not a massive amount left anyway. So obviously, as part of you knocking off this head and adding a new head, right? There's no. So the really sensible stuff and the stuff that's been trained, you've gone knocked off the head. You've added your own bit, but clearly you're a little bit concerned about the bits that you've added because it's going to have a whole lot of random weights, and you need to train that. And that's exactly what you do in that next section, where you do learn.fit one cycle. And that's where basically you're training just the head portion that you've added there. And the next thing that you can do is to save it. Now, if you want, well, I'll stop there actually, and I'll go on to the next section. What's really good then is that at that point, right? So when we say one cycle 4, that means basically we have 4 epochs through our data. The next section is, now you have an opportunity to see where your model is going really wrong, right? So you can see that is it making mistakes consistently, and then perhaps there's a problem with how actually the model is distinguishing between different images. Perhaps it's not using what you think it is, right? And it might be using something totally unexpected. Like was found in, there was once a means of separating a certain kind of dog. So I think a certain kind of dog, 2 different kinds of dogs, and it was found that actually the means of determining them was actually the environment rather than the dog itself. So this is a really great way for you to actually have a look at your data, see where your model is going wrong, and then try and see whether you can make any changes and go back before you do any further training. Now, so hopefully you can see that at this point, right, we've taken the old model. We've taken this old model with this multiple layers, we've added our layer, we've gone and done the training for that extra head. And what would be a really good idea is to train the entire model now, right? Because hopefully if you do that a couple of times, hopefully you'll end up with better results. So it can almost merge the two. The fact that you've added your own head, you've got the previous model. Now actual data can, or some of the differences in the weights that you have can actually transfer between the two. And so that's what you do as part of your learn.unfreeze. And then so you're unfreezing the entire model now, and then you are doing a couple of learning steps again. And what Jeremy and team found out was that actually if you change that so that you're not using a constant learning rate, but you varied your learning rate across your model, so that's across the different layers of your model, that seemed to produce a better result. And it wasn't just a case of, so you can see in this, I'm sorry, the diagram's really small, but you can see that at 10 to the -3, there's already a massive increase in the loss. So your y-axis is the loss, your x-axis is your learning rate. And if they found, for example, that if you actually have different learning rates for different parts of your model, that helped to provide a more or a better means of determining what that learning rate, because the learning rate over the last few years has been quite elusive, and people are trying to figure out what's the best learning rate to actually train your models. And they found that actually being able to split it out or to use it across these different values has proved to be quite helpful in terms of the accuracy you actually get at the end of your result. So that's with the ResNet, I think it was the ResNet 34. So that means it had 34 layers. You can then try it with the ResNet 50, right? Because the ResNet 50 has 50 layers and it gives you a little bit more, it gives you slightly better accuracy in terms of what you can train with your model. And that's basically what we are trying to do in that first lesson. Reuse someone else's model, train our own head, train the entire model, see if we can get a good result. And it's pretty impressive that, you know, just a couple of years ago, there was no way for us to be able to get anywhere near this sort of level of being able to distinguish images. And so this is quite an exciting time to be part of the whole deep learning story. And I think what's nice about the Fast.ai bit is it gives you some really good results fairly quickly without you having to do a massive amount. Any other questions or thoughts or?
Yeah, this is Marcello again. If there is time, I have a question about learning rate and selection of the learning rate when you want to refine your result. In the lesson, actually, we have seen two examples. One is the one on ResNet 34, which is the same one you mentioned before, where basically the loss is fairly low until, I don't know, 10 -3 or so, and then rise up. But then it's pretty clear when he does, when the teacher does fit one cycle on a slice of learning rates, it takes a slice between 10 and -6 until -4, which is pretty low and flat as a loss. But then in the example of the ResNet 50, the learning rate curve is totally different. It's pretty high for the lower part of the range of the learning rate. Then there is a sort of valley around 10 -2 and -1, and then rises again. But when the teacher does the fine tuning as a slice, he takes apparently the range where the loss is higher. I don't know if you have in mind. You have not the picture in your document, but it's
right. Okay. I'm sorry, Marcello. I missed that because I always thought that he always went before the turn. So that's why he would have gone, for example, for 10 -6 to 10 to the -4, and he's done that fairly consistently. I'm not aware of him doing the other things. Does anyone else who knows what Marcello is referring to want to comment?
If you want to share my screen for a second, I have it ready. If it's not too late.
Yeah, go for it.
I'm not really sure, but my question is in the same vein as Marcello's. So you've shown the learning rate kind of being different at different rates, and I've read that it's actually good if you have a decaying learning rate. So for example, in the beginning you have a very big learning rate, and then you decay it such that you can, like you said, it's actually proven that you can get better accuracy with that. But in this particular graph, it looks like the learning rate is actually exponentially getting bigger. Yeah, which makes sense.
Yeah, the other one is this one, which is the one with ResNet 50, where learning rate stays up until this valley here in around 10 -2 and -1. And the strange thing, which I don't understand, is that when refining the trained model here, then the attempt is done here in a slice between 10 -6 and -4, which is where the loss is apparently very, very high. So I would have expected to have some exploration of a learning rate here in the lower part, but it's not.
So I think that question's come up a few. So Marcello, thanks for sharing. I think that question's come up a few times. I think he does come back to that, I think in lesson 2, but I think his answer to that is that those changes are always made before things go downhill very quickly. So, you know, instead of going at e to the -1, for example, he won't stick to he won't do e to the -2. He'll do something a little bit earlier. That was so. I think if you stick around a bit, I think he something very similar comes up again, and and that's exactly the answer you get. So I don't think you need to get too caught up on the fact that it's, why is it -3 instead of -4? I don't think that matters in the grand scheme of things. I think the key point that he's trying to make is make sure that it's in this area. So make sure that it's somewhere between e to the -6 and e to the -3, rather than say e to the -2 or e to the -1, because by then it's already too late, and the change has already happened.
Okay.
And also, just to add on to what John was saying, Marcello, so basically when you see this function, it says slice of 2 learning rates, right? As you go ahead in the lessons, you'll understand that there's a concept of differential learning rates being kind of applied, where there is a lower learning rate for the earlier models and a higher learning rate for the later models. And that's what I think he has used in this particular example. Why these particular learning rates apply and why they need to be applied differently is something that he explains as he goes forward in the lessons. But basically, he also kind of explains in the course that this is for you to get a starting learning rate, which otherwise you have to struggle to get, kind of from. It's an art usually to get a right learning rate. So you take it from that perspective, and as you go along, you'll be able to understand why is that so.
Yeah, and just to add to that, Marcello, one thing you might be interested in is you can look up this one fit cycle that's actually taken by. So those ideas are actually taken from another academic. I can't remember his name. Something Smith.
Leslie Smith.
Leslie Smith. That's the one. Yeah. So if you're really interested in it, you can dig a little bit deeper there, and that will give you some ideas.
Are you sharing a link for this?
No, just Google one. What's the thing called? One. Just Google fit one cycle. Or I'll post it on the. I'll post it on. Okay, we're 5 minutes past the hour. So, any other final thoughts or questions? Actually, we probably need to have a chat about what's happening next week, don't we?
Great. Thanks, John, for the detailed walkthrough through the lesson. So for people in the study group, I have also posted a link on a detailed notes on the lesson 1 done by one of the people who took the course as a part of the fellowship. There is also another link shared by Mikkel on the one done by Hiromi as well. So feel free to dive into that and walk through the notes as well. As John said, we are 5 minutes past the scheduled time. What I would like now is to understand, what's the kind of, volunteers that we have for presentations next week, any discussions that the team wants to take up now and clarify, and let us address that as quickly as possible.
Yeah, as I volunteered to present a paper, I have found one and I can chip that in real quick and get to know, or you can say if it's interesting for you. It's in the Proceedings of Machine Learning Research, Independent Causal Mechanisms by Bernhard Schölkopf and Giambattista. I'm sorry if I pronounce his name wrong, Parascondolo. So that would be one option, so to speak. And then, sorry, let me get that real quick. No, I don't find it any longer. The other one is Artificial Intelligence for Regression. It's a master thesis at Oxford. Anyone interested in either of those topics, or?
So
I'd vote for the first one.
For the first one, okay.
Oh, come on, Joseph. We could have had an entire master's thesis in 20 minutes.
Right.
Anyway, thanks for that, Philip.
Yeah, then I will do the first one, okay.
Okay, can you put that on the chat so we can...
Yeah, I will put it on the chat. Let me do that real quick. Yes.
Thank you so much.
It's here, yes. Copy
maybe you want to share a link to both. I think
yes,
Jess is interested in the second.
I put it in the chat, and you're definitely right. I will also share the link for the second. You're right. Yeah, let me just get that real quick.
Apart from that, I could try giving a more code side walkthrough of the image augmentations for the next meetup, like a few examples based on the standard CFAR or so on and so forth datasets.
That'll be great. Thanks, Sanyam.
Sure.
Okay, so I think, John, are you doing the lesson 2 yourself, or is it any other one?
Yeah, I'm happy to do the lesson 2. I'll do a shorter one though. So if you got 2 other presentations, so maybe give everyone 20 minutes, and that might be the best.
Okay. So we have then 3 presentations. John will walk through lesson 2. Philip will present the paper, and then we will have Sanyam doing the detailed walkthrough of the code behind the image augmentation. That'll be great. So
I could do another one if you want 4. Something I've done off the first lesson, and it's a practical one. It's trying to find defects within leather using the first lessons classifier.
Charles, you know what? You bought yourself a space and slot in next week. I think let's stick with 3. Okay. And no. So it would be really. I mean, if it's relevant to what you're doing, so why don't we go with your one, Charles? That would be really handy. And then
it's very visual, very accessible, I would imagine.
Sure, I could move my example to the next.
Yeah, I mean, and to have a pipeline of presentations is to be in a very good position. So
absolutely.
Okay, so I'll count myself in for next week.
Okay, great. And if you have a notebook, Charles, that you want to share in advance, or anyone in general, I think that would be handy.
Yep. I've got to figure out how I do that.
Yeah, just post it on the channel for, the Slack channel for
DL, I think fast_a_DL.
Mm-hmm.
Also, a quick announcement to anyone new who has joined us today. I have a decent enough rig that's based on 2080 Ti. So in case anyone wants to explore more ideas outside of the lessons, my server is sort of available. Please feel free to reach out to me.
Also, people who are coming in new, one more appeal is, please participate. Feel free to ask questions that you don't understand. Every question is important. Every question is good. We will try to answer as much as possible. And also, please take this opportunity to start going ahead and do some presentations. It worked for me, and I hope that it works for you as well.
One point about the notebook. How do you get the data up there? Because it's like 500 meg. Or do you just want to see the
well, I'll tell you what. Well, if you have it stored somewhere where you can make that link accessible, I don't know if you did you say 500 meg? 500 megs. Mm-hmm. Yeah, I mean, if you have some sort of a shared folder or storage on S3 or something like that, I don't know.
Or you could upload it to Google Drive if that's convenient.
Well, I'll just throw up the code so far.
Okay. Yeah, actually, that's a good point, Charles. Google Drive gives you 12 gig, so that's an option if you're interested. And then you can easily access that from Collab, so someone can just copy that over. That would be handy.
So Ravi, just for your benefit, what Sanyam was referring to is a deep learning rig that he has, a 2080 Ti based rig, which is currently with capacity, which he is willing to kind of share length for interesting projects, and you can discuss this offline with him.
Wow, cool. So what's your email address? Or how can people contact you?
I'll leave my handle and email in the chat.
Okay, so for 3 things for next week then. So one is the lesson 2 review by John, then we have the presentation by Philip, and then the paper, the notebook presentation by Charles, right? So that's the 3 things we agree.
Yeah.
Okay. Anything else, folks?
Yeah, Marcello again. I'm looking for the Slack channel link, but I'm not finding it. Can anybody help me?
The link to the Slack channel. Okay. Maybe we can. Okay, if I don't post it here, you will not be able to participate in that. Okay, so if anybody can put that right now in the chat, please, for Marcelo.
I think for the Slack invite, you need to sign up for the.
Okay.
On the TWiML side, yeah.
So I think Vikas has posted Marcelo for you.
Thank you very much. I've seen it. Thank you very much.
Okay. So yes, Deepthi, I think the plan is to watch lesson 2 before the video, and so that we are all updated and we'll be able to follow the lesson in a much more important detail. Yes. Okay. If we are all good, then we'll call it a day and then regroup next week with the 3 interesting presentations lined up. Thanks all of you for joining, and have a great weekend.
Thanks everyone.
Thank you.
Bye-bye. Thank you very much.
Bye.
Bye.
Thank you.
Thank you, everyone. Bye-bye.